Hello, everyone. Welcome back to the Machine Learning course. I hope you've completed the previous phase because today we're starting phase 3, where we'll explore one of the most important topics in machine learning regression algorithms. Before learning algorithms like linear regression, ridge, lasso, random forest, or XGBoost, it's important to first understand what regression actually is and why it's used. In this video, we'll build that foundation so that the upcoming algorithm videos become much easier to understand. So let's get started. Here's what we'll learn in today's lecture. First, we'll understand what regression is and why it's considered a supervised learning technique. Then we'll compare regression and classification, since many beginners often confuse these two concepts. After that, we'll briefly look at the different types of regression algorithms that we'll study throughout this phase. Next, we'll explore some real-world applications to see where regression is actually used. Finally, I'll explain the complete regression workflow from collecting data to making predictions. By the end of this video, you'll have a solid understanding of regression and be ready for the upcoming algorithm lectures. So what exactly is regression? Regression is a supervised machine learning technique used to predict continuous numerical values. In simple words, whenever we want to predict a number instead of a category, we use regression. For example, predicting a house price, a person's salary, tomorrow's temperature, or the sales of a business. The model learns the relationship between the input features, which we call X, and the target value, which we call Y. During training, its goal is to minimize the prediction error by finding the best relationship between the inputs and the output. The example shown here is house size versus house price. As the size of the house increases, the price generally increases as well, and regression tries to learn this relationship so it can predict the price of a new house. Since both regression and classification belong to supervised learning, it's easy to mix them up. The key difference lies in the type of output they predict. Regression predicts continuous numerical values like house prices, temperatures, or salaries. On the other hand, classification predicts categories or labels, such as spam or not spam, disease or healthy, or cat versus dog. Their evaluation metrics are also different. Regression models are commonly evaluated using MAE, MSE, RMSE, and R-squared score. Classification models use metrics like accuracy, precision, recall, and F1 score. So remember one simple rule. If the output is a number, use regression. If the output is a category, use classification. There are many regression algorithms, and throughout this phase we'll learn them one by one. We start with linear regression, which models a straight-line relationship between input and output. Then comes multiple linear regression, where multiple input features are used to predict a single output. Polynomial regression helps when the relationship isn't linear and follows a curve. We'll also learn ridge regression, which helps reduce overfitting using L2 regularization, and lasso regression, which uses L1 regularization and can even remove less important features. These are just the beginning. In upcoming videos, we'll also cover advanced algorithms like decision trees, random forests, XGBoost, light GBM, catboost, and many others. Regression is used almost everywhere in the real world. In real estate, it's used to predict house prices. In finance, it helps forecast sales, revenue, and even stock prices. In weather forecasting, regression predicts temperature and rainfall. Retail companies use it to estimate future product demand and inventory requirements. In healthcare, it can predict medical expenses and patient risk scores. Even in human resources, regression is used to estimate salaries based on experience, education, and skills. These examples show why regression is one of the most widely used techniques in machine learning. Let's understand the complete workflow of building a regression model. First, we collect historical data that contains both the input features and the correct target values. Next, we pre-process the data by handling missing values, removing outliers, and preparing it for training. Then, we split the dataset into training and testing sets. After that, we train our regression algorithm using the training data. Once the model is trained, we evaluate its performance using metrics such as MAE, MSE, RMSE, or R-squared score. Finally, if the model performs well, we use it to predict values for new, unseen data. This workflow is common to almost every machine learning project you'll build. That brings us to the end of today's lecture. In this video, we learned what regression is, how it differs from classification, explored the different types of regression algorithms, looked at some real-world applications, and understood the complete regression workflow. This foundation will make the upcoming algorithm videos much easier to understand. In the next lecture, we'll begin with simple and multiple linear regression, where we'll cover the intuition, the mathematics behind the algorithm, and implement it step by step in Python. If you found this video helpful, don't forget to like the video, subscribe to the channel, and turn on the notification bell so you don't miss the next lecture. Thank you for watching, and I'll see you in the next video.